Okay, welcome back to tutorial number 3. We're going to be demonstrating how to choose a rough boring bar and come in here and rough this ID out right here all the way through the part. According to our print over here, we right now have a 2-inch or actually an 1 3/4 hole through here, and now we want to remove all this material right here through another roughing operation. So I'm going to come over here firstly, back to here. Now we need to select a boring bar. So I'm going to select tool change, and I'm going to select category. I like using C&MG tools. And here you can actually pick a bar diameter, and then up in here it'll actually tell you the minimum bore that typically that tool would get into. So I got an 1 3/4 hole, so the minimum bore that an 1 3/4 tool would fit in would be the 1 3/4 diameter, which is the hole size that we drilled. That might be cutting it pretty close. If you've ever done a lot of machining, and if you get too big a bar in there, those shavings won't flush out. You'll start jamming and breaking tools and tearing up your part. Bad stuff happens when you get too close. So you may or may want to go to an 1 1/4 bar, or you may want to stick with the 1 3/4 bar, and it will bore the clearance that it needs. And if you don't run the RPM too fast, then you may not have any problems. For demonstration purposes, we're just going to pick an 1 1/4 bar. And we'll select OK. And again, we're going to go through the process of selecting our tool. I'm going to put this on tool number 7. I'm going to use offset number 7, a tool tip type 9. And I haven't really described to you as yet what all the tool tips are, and I'll show you that here shortly. But basically, when you pick a tool from the library, you should never change that tool tip number. It's unless you really know what you're doing. The tip is set from the tool library. It knows that's what type of tool that is. Basically, it's how it calculates the cutter count based on the tool tip number. And I'm going to give it another X10, Z8, tool radius of 31, max spindle speed. Again, I'm going to go to limit it to 1,000. I'm going to run it at 500 surface feet, spindle forward, 254, and using the C&G 432. That should be a 1/2 inch IC insert. And I'm going to change my text comment here to say, I'm not going to rough and finish. I'm just going to do a roughing operation. So I'm just going to tell it rough the bore. Now I have my roughing tool sitting up here at this index position, and again I need to rapid it down into here so I can begin roughing. So I'm going to firstly select the rapid command, and I'm going to rapid it to X of 1.75 and Z 1 inch. Then I'm going to rapid it again up to Z 0.1. So that kind of gives me a safety move to here, and then a move to here that I can start now stepping it off this process here. So again, just like we did the roughing operation on the OD, I'm going to start by doing a rough turn-in cycle again, which it's also not rough turn also does a rough bore. So you can just do a rough turn, which is going to output another G71 cycle. Start from 1.75, Z.1. Again, the stock right here, be careful when you select stock, because stock can be plus or stock can be minus. It knows you're doing a borer, so it automatically took your default of 20 thousandths that you like to leave for finish pass and converted it and tells you, well, since you're on the ID, you probably want to have minus stock, which would be correct. I'm going to leave 20 thousandths in the minus direction, plus 5 thousandths in Z, the depth of cut, let's go with 100 thousandths per cut, retract amount, and the feed rate again. Okay, once I have turned on the rough profile cycle again, the method of what you're going to do is program the finish tool path that you'd like for this particular to draw the shape. So I'm going to go back over here to my picture, and I can see my first diameter that I'm going to do right here is 6.52 plus 15 thousandths, so 6.535. During a roughing operation, sometimes, if I have a big radius or a chamfer, I might want to chamfer this little corner right in here with this roughing cycle, but sometimes, it's irrelevant because it's I'm only going to put maybe a 10 thousandths radius or a 15 thousandth chamfer. I can do all that in my finishing operation. So at this point, what I want to do is I'm just going to leave that corner sharp, and so I'm just going to use just a point to get to right there. Then I'll use a radius into here. Then I'll use a point right here, and then I'll do another. So basically, I'm going to do just one radius and a couple of points. That's all we're going to have to do to create this roughing cycle. So 6.535 would be my first point. So let's come back over to here, and I'm just going to go to point 6.535 at Z0, the face of my part. That's my first point, starting right there. Your first point is not way back in here somewhere. Your first point should always, I'm going to say that again, should always, typically, not always, but pretty much always, you're going to start at Z0 for a roughing operation, like for facing or turning as we did here, and boring as we did here. If you're doing back turning, it's not going to be 0, but for anything that starts out the face of the part, the first point is always going to be Z0, and then from there, you'll create the rest of your path. Okay, so let's go back and now let's look at my print again, and I can see that I have a depth here of 2 inches. That's this point right here. How we generate this point right here is, if you were to look at this diameter, just think as if there was no radius here. If there was no radius, well, you would just select point, right, and go back 2 inches deep and then down. Well, that's basically all you need to know is where that theoretical sharp corner is. This intersection back in here is all you need, and then tell it to radius that fillet, that little corner right there. So we're going to go minus 2 inches at that 6.535. To do that, the easiest way to do it is to get a free ride. I can give you a ride all the way down here or around that radius and get you pointed in the right direction going down using what's called the arc corner. Okay, what it wants to know is where the theoretical arc corner is. Again, let me say this again. If there was no radius there, where would you be cutting to? Okay, well, I'd be cutting to 6.535 and Z of minus 2 inches. That's the point that I would tell it to go to if there was no radius. It's just that sharp corner. That's the corner that it's asking for, is that information. It's going to automatically calculate where the radius starts and where the radius ends for you. We've got a 1/4 inch radius. And in here, you got 2 questions about the angle and on how to get to the radius and which way you're going to go after the radius. Right now, it's going to ask you, what angle will you be moving towards the arc? Well, the tool is sitting right here. If I'm going to be moving towards that arc, I'm going to be moving straight to my left. Again, if I look at my compass, that angle would be 180 degrees. So I'm going to select 180 degrees. And the next angle is going to be the angle you would be moving after the arc. So after we turn here, we fork a radius, and we're going to be going down, straight down. And if I'm going straight down, that means I'd be going 270 degrees. So I'm going to tell him 270. And I'm going to be moving around the arc in which direction? Clockwise or counterclockwise? This is going to be counterclockwise. And I'm going to keep the cutter on the inside or outside of the arc. This is not asking you, people ask me this all the time, are we cutting on the inside of the part or outside of the part? This is not an inside or outside of the part question. It's the tool, the tip of the tool. Is it supposed to be cutting on the inside of the radius of this 1/4 inch radius, or is the tool path going to be on the outside of the radius? In this case, it's going to be on the inside of the radius. And then at a feed rate, so it's going to generate a line, a circle, and another line. This is typical. It's going to show you a full circle right here. Okay, and once you do a redraw and you tell it the next point, it will actually it'll trim this circle for you. So my next point from here is to come down here to some new diameter. That new diameter is to come down to this x 2 inches plus half my tolerance, so it would be 2.015. So I'm just going to tell it point. X 2.015. Z, stay at minus 2 inches. I'm going to be traveling 270 at a 10,000 speed rate. So it's going to make it move down to here. And again, if I do a redraw, you'll see now it's actually trimmed apart. From here, I need to bore through my part. I'll go back to point, stay at 2.015 minus 4.1, let's say, at an angle of 180. That'll bore it completely through my part. And then I'll move down to, I never leave my tool sitting on the part shape. Always make it on your last move should always be a move away from your part material. Whether it's on an OD, you can move up. If it's an ID, you're usually going to make a move down. So I'm just going to tell it point, move down to some dimension. In this case, let's go with 1.75 minus 4.1, angle 270. I'm just going to move I'm making a straight move down in this particular case. Again, what I want to do now is there are no more points. I always end it by selecting the tool comp so that I can look at the tool compensation path and make sure that I did get the arc radius is correct and make sure that the tool path is on the correct side of my profile. Okay, here's my tool path. Yep, it's on the inside of this radius is where it's going to go. I can see my tool path is correct in the roughing cycle, and it will begin the roughing operation. And again, I can slow it down a little bit if I wanted to. Watch the whole thing. It's a rough turn. There's my drill. There's my rough bore. Okay. The only thing I have left to do now is to send this tool back to home. So I'm going to select the little house, which is home. Go back to X10, Z8, Op1, optional stop. I can just hit accept. I can accept all the defaults and send it straight back home. All right, that's the end of our third tutorial and how to do a rough boring operation. So stay tuned for the next operation. We're going to start doing some finish work.